Awesome. So our next speaker for the day is Bennett Hiles. Bennett is a staff software engineer at Perennial Earth for the last 1+ years. Bennett has a wide range of experiences. I was looking at your LinkedIn profile and I found that you had worked at companies like Coinbase, Button Inc., O.SM, and many others. And of course, at Perennial Earth, you're focusing on ML and ML ops. So Bennett, welcome to Metaflow Office Hours, and over to you.
Yeah, thank you. Excited to be here. Yeah, let me just present the screen. So, yeah, brief context. Ben and I work at Perennial. Perennial is, trying to, where do I see my screen very well? Yeah, Perennial works to get carbon credits for soil. People know this exists for trees, but there's actually a way you could get this for soil for farmers. The high level of it is take satellite images plus ML plus some actual samples of the raw soil, and now you can try and make this a cost-effective way because each soil sample is really expensive. So if we could use ML on top of it, we can make it cheaper. I work on the data engineering side. We're a small team, so we we previously weren't using Metaflow, but I was seeing kind of the benefits of where Metaflow fit in and was like, cool, and we were able to move a bunch of our jobs over to it. Then when thinking about kind of how are we going to handle this for orchestration, we're already using AWS for a bunch of other things, so AWS seemed like a perfect solution. So we started using step functions with AWS batch jobs. I know that's like one of the legacy kind of orchestrators for Metaflow, and I feel like most folks are now using like Argo, and that's kind of where a lot of interest is. But I want to like hugely pump up like step functions are hugely valuable and really, I mean, definitely not for the other presenters' use case. I think you guys want isolation. You're not going to get that maybe with this, but for small teams that just need to kind of scale, the huge benefits of step functions, so, like you don't have any idle costs, so you're only paying for when you're running things. Step functions have been around AWS for a while, so they're really battle tested and they have an amazing uptime. And I don't have to deal with any of the operational complexity with that. They're just there running, working. And then Metaflow, like sprinkled on top of this, just gives us a really like step functions in themselves have this crazy DSL. And like you can try and create stuff yourself, but nobody really wants to. So Metaflow gives you that really easy way to just write code, and then it will map to step functions. You can write really complicated DAGs that go really wide, do a lot of functionality. But the limitations. So the max concurrency you can have, it defaults in Metaflow, I think, to 100, but in step function, it actually limits to 40. And that's just by default, like part of step functions, like the way it works with Metaflow is it just caps out there, which is just, limiting. And then on top of that, it has this idea of like entries. And essentially every time you launch a step, it creates 3 entries for that. And there's a max of 25K. Which means you only get 8,000 about, which means if any job has a big for each and then another for each, like you just can run into issues. So you have to, it's limiting. So these impact, the impact of this is like jobs can't complete quickly because you can't go as wide as you want to. Developers need to plan about the concurrency of their jobs for like how many loops they want, for a for each. Can it just be each item, or do they need to actually, chunk items together? And lastly, these issues don't actually manifest like right when you like deploy and kick off the job. They actually manifest midway through it. So it's like, concurrency, it manifests actually because you're looking and you're like, why is this taking so long? Oh, okay, it's limiting on how many it's going to send through concurrently. And then with the 25K, you don't actually discover that till you hit that limit. And then boom, your job's just destroyed. And you're like, an hour in, you're like, oh crap, like that. So, the root cause of this is okay.
Sorry, is the max concurrent limit to 40 or setting to 40 as the default? Is that a limitation on the step function side, or is it just an artifact of Metaflow?
Yeah, perfect question.
Oh,
It's actually, it's a manifestation of Metaflow with step functions. So there's two modes. So when you're doing a for each, intrinsically step function creates this map construct, and step functions like when they were created had the map concept of what they later titled inline, and it intrinsically maxes out to 40. You could set it to lower, but you can't set it to higher. You could set it to higher, and then it's just going to still just chunk up 40 at a time. But in late 2022, they released this distributed mode, which then lets you actually go up to 10K. So like miles and miles better. But it now like has a different kind of paradigm. You have to kind of work with its functionality. Like mentally, it essentially creates an entirely new step function. So that lets you get away from kind of the limitations that one had. It like branches off and creates a child step function, and then just has ways to kind of tie the two back together. So the solution, just use it. Use this new functionality. Well, it's a little finicky to muck with this, how it all works. So I created an PR in GitHub to do it. It was kind of my first tack on it. I've since forked that so that we can kind of run it internally, and have extended on top of it and been working with it more. But I don't know if there's like a lot of interest in the community, so we'll get to that later. But so there's a PR. The way you use it is when you can just use this when you're creating a step function. You use an additional -- use distributed map. So to kind of just look at like a really simple example of how this would look in the before and in the after. Like here's my hello to n. And it's meant to be like hello to n people. And so like I can select how many people I'm going to say hello to, and it just defaults to 10. I'm just going to get, the number of people to say hello to. In my start step, I'll say hello to them. So this will like hi to 1, hi to 2, hi to 3 in each step. That way I can, fan out really wide. Then I just join it together, and then I end it. I put some like resource limitations here just to like, I don't need 4 gigs of RAM for any of these, so I want to just make it smaller. Before, this is how I'd run it. Create the step function, then trigger it with the number of 100. The DAG's going to look like this. Here is the beginning of the DAG. Here's actually the start step. Hello is a unique kind of like this hashtag or pound hello is actually a unique step. It actually saves data in Dynamo. That way, because we need to, when you do a map, you need to store a little bit of state. Like step functions work in this way of like, you need to kind of pass data between the two, and there is a mechanism to pass the data, but it's a little finicky to deal with. And so there isn't all the data you have available. So this is how it works to begin with right now with step functions. It stores some data in the hello step in Dynamo. Then this is actually the map function. It like maps out and then runs the hello. This is called like, this is map hello, and this is like run the hello step. And then it joins, and then it ends. And a really helpful kind of piece of functionality is if you click on this, you could actually see kind of how many have started, how many are in progress, how many have failed. It gives you like a really clean view of the step function. And you can't, maybe if you kind of squint at this logic or just listen, like you can see here's all the map iterations. I had 100 specified. You could see it doesn't, a bunch of them kick off at the same time, and then a bunch of them kick off later. And that's because they're not kicking off until other jobs have been completed. So it's, shows a rolling 40. Conversely, I can run it and use distributed map, same functionality, but now we're going to get little different functionality. So here we're still going to save stuff in Dynamo. Here I'm going to run my same logic, but now I need to, essentially now I'm doing a distributed map, and I need to like fetch the data back to pass it through the function. And when I tried just doing simple ways, step functions have a limitation on how much like the payload size that you could pass across. So I couldn't just like grab the results ingest it and move on. So instead, I actually run like, here I get the S3 results, and then I have to do like a second map job just to pass the data across. This was hacky. It's not my favorite approach, but to get things working, this it gets us there. And so then we actually end up with a different kind of interface. Like here, this is where you see all the maps, and this is going to be 100 of them will be recorded down here, and it can kick off 100 simultaneously. So it gives you kind of a different UI, and didn't give us that like really clean interface like at a top level. So you have to kind of click through, which is unfortunate, but it gives us the scalability. So the pros supports up to 10K iterations. No limitations on the 25K events, but we have like way less visibility into the original structure. So under the hood, we could try and decide like, oh, some maps, make this map do distributed and this one do not distribute, do inline mode. But I was like, for simplicity's sake, let's just make sure every map is a distributed map. That will make sure for a developer, like, although you lose the kind of UI visibility, you get the clear functionality of not having that 25K limitation. Passing state around, is really difficult. Like the functions I need to store it's a child step function. So you actually have to store more data in Dynamo. So because it's like, doesn't know its parent node, and actually could have like, the parent child relationship can keep going down, because you could do a map, another map, another map. I had to do this like the distributed, I had to jump through hoops to kind of get the distributed job to handle the payload sizes, with such having that second job. And then interesting, I ran into this one when I started like kicking off like massive amounts of jobs, 1,000 in parallel, was like retrying that under the hood. So this is step functions are actually creating batch jobs. And batch has a limitation of creating 50 a second, which, this goes like nicely in line with like, oh, we only created 40 previously. So I create like this retry policy, which only retries on the batch exception of it not being able to create the job, not like your jobs exception. And that way it'll retry, for, like 200 times. This is like giving you enough retry attempts to get this job through, assuming you had 10,000, what's it called? Concurrency 10,000, which, I haven't hit yet, but, so I've been using the forked version, but I don't know if people are interested, and I could try and move things back. So if people are, thumbs up the PR, and I can, I'd be happy to kind of move more changes back. I have extra stuff on testing, but we're kind of over time, so I'm happy to pause here.
This is awesome. I mean, I again, it definitely is one thing to kind of sort of use Metaflow as is, but I think it is a fact, like one of the basic tenets of Metaflow has been that, build locally and then run remotely. And then this run remotely part therefore works on different backends like Kubernetes and step functions and batch and stuff like that. And those things are also evolving every now and then. Kubernetes is changing, AWS batch, AWS step functions is changing. So keeping up with kind of sort of improvements that are happening in those backends is a real, requires real work. And the fact that you've gotten over all those limitations, it almost to me felt like I wasn't aware of the limitation of 40. It felt to me like a parallelism of 40 kind of sort of suggested it was for maybe medium-sized workloads at best, right? Like 40 seems very low as a limit. Like we oftentimes like hear about running, especially in the Kubernetes land, running for eaches which are like hundreds, if not thousands in parallel. So 40 was too low, and maybe now they've kind of addressed that, but yeah, it requires work to get there. So, this is great stuff, really cool.
Yeah, exactly. 40, like squinting at it, it's like, okay, it kind of works, but then, it was like, oh no, this is not going to work for our workloads. And you want to kick off, you just don't want to have that limitation. Like, maybe you need to go that wide, but when you do, to say that your tool can't handle it, like, it's frustrating. And I feel like, I imagine folks have tried step functions and have moved away from it, given this kind of limitation.
Possibly. Possibly. How common? So you mentioned about one of the limitations of moving to the distributed map with 10K parallel, with a possible parallelism of 10K, is that the UI on the AWS side looks different, and therefore there is different visibility. Um, how common is it for anyone to kind of sort of start a job using Metaflow and then switch over to the AWS console for looking at how it is going and things like that?
Oh, that's how all the jobs are. Like we use the AWS monitoring for that entirely. That way we don't have to we just run almost everything as like Lambdas. And so there aren't really any long running infrastructure that we have. So we don't have like the Metaflow kind of UI set up anywhere. It's really just like this gives us all that visibility.
So Metaflow gets used kind of sort of as a user-friendly way of creating the job DSL or the step function DSL essentially. Like using Python code, you become, instead of having to write that DSL by hand, Metaflow becomes the way to convert good, easy, structured Python code into that DSL.
Entirely. And then like the second part of it is like the testing, because like I also really cared when introducing Metaflow. A big part was end-to-end tests, that we're going to run a flow and make sure that people can know that it's going to work. And like there already is a way to kick it off. The thing we built with just locally was a way to run it all in Python code. That way you can mock out functions and like get all the assertions. So if something raises an error, if you want something to hit like local endpoints, because some of our jobs like actually reach out to external APIs.
Got it.
You just gotta jump through hoops.
Any questions? Anyone else?
So if I understood it correctly, you only rely on the AWS console also for monitoring and UI. You don't have the Metaflow UI.
Exactly. Yeah. The AWS UI is pretty good for showing all that. So we just haven't turned to it yet, the Metaflow UI, but maybe in the future.
Okay. Yeah. It also makes sense with the narrative that with lambdas and step functions, you only pay as you go, and UI is something that would need to be. Because while you were presenting, I was planning to ask with these concurrent executions of step functions and this 100 of executions being listed, I was curious how Metaflow UI draws that in the diagram. Okay, I guess we'll never know.
Never know.
Cool. Anything else? Going once, going twice. Cool. Anyway, thank you so much, guys, for these presentations. These are really awesome. We learn a lot through these. We learn about new things. I learned new things about step functions. I did not even know that they had a limitation of 40, and I did not know that there was a newer implementation with this thing. I did not know about on-prem Kubernetes is its own flavor. So thank you to our friends at DeepSense for kind of sort of presenting that. So thanks a lot for these. And as I said, we'll have these. This is getting recorded, so we'll have these videos, two videos, one for each presentation, up on YouTube at some point, and I'll share those links with you guys. And then our next presentation our next Metaflow office hours is going to be on January 16th. So I'll send a message so that everyone is aware of it. Thank you so much for joining us today.
Thank you. Have a nice day. Bye-bye.
Bye.
Thank you so much. Bye-bye.